On question 4, we were trying to tie together our Power Lab by applying this to a practical problem here. It says, this is the classic guilt problem. If you ate a package of plain chocolate M&Ms that has 240 calories, capital C, that's a food calorie, so be careful there, that's a kilocalorie, how long would you have to run the stairs based on your power rating for the slab in order to burn it off? Okay? So, step 1 is, when you're trying to solve something, make a little what? Make a little sketch, right? Okay? You know when you go to the gym and you're like working out? A lot of times like on the treadmill machines and exercise bikes, you can enter like your weight, put a little sweatband on there, and it tells you how many calories you're burning. Well, this is how the machine's trying to do the calculations. But it's just kind of estimating. We're going to actually use real numbers and real data that you collected to figure out how many calories you actually burn off, okay? So in other words, if I chowed on a package of M&Ms right here, how long would I have to run up and down these stairs in order to burn it off? It's as simple as that. So really, what are we trying to solve for? What's our unknown here, guys? We're trying to solve for what? Time. Time is our big unknown. Okay? And the time is going to be affected by two things. One is, well, what is your actual power rating? Right? And power is equal to what over what? Work over time. So the key is, the work that you're going to do is going to be equal to the energy in a package of M&Ms. So that's what that 240 calories is, with a big C. Okay? So the first thing we're going to do is we're going to use somebody's power rating as an example. Someone want to volunteer? Their power rating? Anyone want to know how long you have to run and burn off a package of M&Ms? Okay, we're going to use Kevin as our volunteer then. He was 882.5 watts. Okay? Another way to look at this is if you had 882.5 watt light bulb and you could burn a package of M&Ms and turn it into electricity, how long would it power that light bulb for? That's another way to look at that. Okay? But basically, based on Kevin's power rating, how long will it take him to turn 240 calories, okay, into heat to burn it off as he runs up and down stairs? Now here's what's tricky. Calories is not our normal unit for energy. What's our normal unit, guys? We're supposed to use, starts with a J. Joules. If you flip over your lab sheet, there's two important facts we need. Yeah, two important facts. We need to know that 1 food calorie is 1,000 heat calories. It's a kilocalorie. And 1 heat calorie is 4.18 joules. In other words, a joule is a very tiny, tiny, tiny unit of energy. Okay, it's a very small measurement. It's like the energy a butterfly uses to flap its wings. Okay, just really small increment there. Okay? So, let's convert. Fun. We're going to turn 240 calories into joules. So we're first going to get rid of big calories and go to little calories. 1 food calorie is equal to how many heat calories, guys? 1,000, right? Just looking off our useful fact sheet. So the calories cancel out. Now we're going to get rid of heat calories and go to what? Joules, right? And in 1 heat calorie, what's the conversion factor there, guys? It was 4.18, right? So now our heat calories cancel out, and we're just left with joules. So in other words, 240 calories, big C, in a package of M&Ms is a ton of energy. It's a lot of joules, okay? So a package of M&Ms can really power your body for a long time. Let's multiply through. So go and get out your calculators, take 240, multiply by 1,000, and then what? Multiply by 4.18. Do we have to divide by 1 on the bottom? We don't, right? It doesn't change it, yeah? And what do you get when you're done? Really small number or really big number? Yeah, honking huge number, okay? I get the work energy stored in a package of M&Ms to be 1,003,200. 1,003,200. Okay? You guys getting that? And the units is joules, okay? That's the work energy. Does it make sense? You want to do that much work in order to burn off that many calories in your M&Ms. By the way, if you picked up a package of M&Ms and it says like 1 million joules, you'd probably like freak out and not eat it, okay? Then again, you'd probably be like, what the heck's a joule? And you'd eat them anyway. Then again, you'd be like, ooh, these look yummy. Except don't eat the red ones, they give you cancer, right? Just kidding. It's like urban myth there, okay? Interesting thing about calories, this candy bar is from the UK. It's called the Turkish Delight, and it actually tastes really bad. Okay, it's kind of like a really nasty Three Musketeers. If you really like it and you're British, like, no offense. It's just our candy bars are better. Yeah, there we go. Anyhow, what I thought was kind of cool is on the back side, on the nutrition label there, notice what do they actually list the calorie content as what? As energy, right? That's kind of cool, right? And notice they gave it in redneck units, in calories, kilocalories, which is food calories. So it's 175 calories for this bar, but it's 730, what's that K stand for, guys? Stands for kilo, right? So it's 730,000 joules of energy, okay? If you take 175 and multiply it by 4.18 and round it off, that's what you're going to get, okay? So that was kind of interesting that the Turkish Delight candy bar, okay, actually listed the actual energy content in the proper metric units, but also in our American units, okay? Anyhow, let's wrap up this problem. Now we're going to look in our step 3. What do you do in step 3? You write your what? Equation, right? I want to know time. I know power is 882.5 watts. I know work is 1,003,200 joules. Which equation is going to work, guys? Equation number what? Number 6 is going to work. Power equals work over time. How do I know which one to pick? I just pick the equation that relates my unknown to my known pieces of information. Step 4, we pluggeth and chuggeth. We take all our numbers from step 2 and we plug it into our equation that relates our variables. What do we put in for power, guys? 882 point what? 5, right? What do we put in for work? 240 or 1,003,200, guys? Yep, 1,003,200. We have to have standard units, okay? And then what do we put in for time? Ha! We put in what? Time. That's what we're solving for, yeah? Uh-oh. How do I solve for something on the bottom? Here's a little trick, guys. This is 882.5 over 1. So how do you solve when something's on the bottom? What can you do? You can cross multiply. Bingo! So now we got 882.5 T equals 1,003,200. Man, that's a real pain to write out. Good thing we'll be done with that number soon, yeah? So how to get T by itself? Divide both sides by what? Divide both sides by 882.5. Get out your calculators. Take 1,003,200. Divide that by 882.5. Okay? And we can figure out then the time for Kevin to burn it off. Of course, you're going to figure out how long it takes you to burn it off, right? Click it. What did you get when you punched it in? Yeah, let's go ahead and round that off. Okay? We're going to round the time to 1,137. And what are the units for times, guys? Unit for time is seconds. That's a lot of seconds. Let's change that to minutes by dividing by what? By 60. What do you get when you do that? Divide that by 60. Yeah, 18.95, okay? We'll just round that off then. 18.95. We'll keep it, okay? It's about 19 minutes. So in other words, you got to keep running up and down those stairs for like almost 19 minutes there before you burn off that package of M&Ms, okay? And that's at full speed there. That's a long time, isn't it? Okay? So it might seem kind of depressing that, man, like we eat all this food, we can't burn it all off. But there's one huge advantage you have as teenagers, and that is just sitting there. Are you burning calories? Yeah, you have your base metabolism to keep your heart beating, your blood pumping, electricity flowing through your body to keep your brain functioning and all that, and breathing, and generating body heat. Okay? What's the average human body temperature supposed to be? 98.6 degrees Fahrenheit in our goofy unit of measurement there. So does that take a lot of energy to heat up all your blood and all that water in your body? Yeah, you betcha, right? Okay? So just sitting there as teenagers, you guys burn tons of calories, which is why, like, when you're growing, you guys eat like crazy, yeah? I remember when I was a teenager, I could eat like 3 Big Macs, no problem, like 2 large fries. Feel a little sick afterwards, but in like another half an hour I was hungry, right? Okay? Now I'm an old fart, kind of slowed down. I used to like to get those burritos as big as your head, except they're really not as big as your head. I'm talking about like at El Famous Burrito, or down at Uvi's place called La Bamba's, but I'm like, man, it's not as big as my head, and I could eat like 2 of those. Now I can barely make it through 1. So anyhow, make a long story short, we could figure out how much time it takes to burn off a certain amount of calories in food. The tricky part was just converting food calories to joules, okay? And there you have it, a little power lab all wrapped up there.